Hello everyone, welcome back to your AD channel today. So today we will discuss this RMS value in AC circuit. This is again important practically because in day-to-day life our home or other AC circuit like wall sockets, any other locations, you have this AC RMS value like 120 volt, 220 volt in your wall socket. So this means your RMS value. So what is this represent? And how do you calculate peak value from RMS? So those things we will discuss in this video. Now, as we discussed before, AC voltages are time dependent. So with time, they are changing. Now, practical world or electrical circuit, we get this different type of AC waveform like triangle wave, a sinusoidal wave, or there are other type of waveforms like this type of waveform. Now, Vm, this is Vt, Vt. If you think these waveforms compare to your DC circuits, DC voltages, like DC you have like this. Now, when you have a DC, your voltage and the resistance make a current flow in the circuit. Similar thing we can expect in AC circuit as well. So when you can think it this way, so what is the power in DC circuit first? So in power, if you have voltage, I write capital letters for DC quantities and simple letters for AC quantities. So you know this current is capital I, therefore your current will be according to Ohm's law, V divided by R. So my power will be instantaneous voltage and current multiplication. In other words, instead of current, I can write V over R, I can get V squared over R. Or you can, instead of V, you can substitute IR, you get power is equal I squared R. This is power in DC circuit. Any DC circuit, you can calculate power using this formula. Now, the question comes to your mind is, when you have AC voltage waveforms like this, how do you calculate power in this waveform? Because they are time depending. With time, they are changing. Suppose if I connect RMS value of this waveform peak value is Vm, and I have VRMS value, an AC waveform, and if I connect the resistor, what is power going out from circuit? And what do I expect? How much heat I expect in front of this load? How much heat I expect in front of this? Now that is what I want to confirm. Now, since this is AC, I can write Vt and current is It. So my instantaneous power, with time it's changing, I can write Vt, It. Or I can write Vt, current is voltage divided by resistance. So I can write instantaneous power is V squared T over R, or I squared times R. So this is instantaneous power. What is instantaneous power mean? Instantaneous power represents the power any given instant, right? Now your voltage is like this. Now this voltage and the current also this divided by resistance, so it may have like the nature like this. So this Vt and It multiplication, right? This multiplication is current. This value multiplied by this value, this value multiplied by this one multiplied by this one multiplied by this one, like that you multiply. Now, for a one cycle period, I want to calculate the average power. So So what is the average? So in order to calculate the average, I know Vt, It. I can integrate this for one cycle. Then I can divide it by the full time. In other words, I can write this average power. So this is P average. Then P average will be 1 over T, 0 to T, Vt. Instead of Vt, we can write Vt over R, dt. Or you can simplify this 1 over Tr, because R is a constant, positive number. So I can take it out, Vt squared dt. So this is my average power. Now this average power, or in front of this resistor, how much heat I feed. Now this average power, you can argue like you get from this AC circuit, you get this average heat from this resistive element. So you can think a DC source, I will mark that value as RMS, that gives the equivalent amount of heat, what you got from this. How much equivalent heat you got, you should get from this DC circuit as well. Now DC circuit, it is easy to calculate the power. You know that is just this DC value divided by the resistance, or the RMS value divided by resistance. So this is the heat amount I get. For AC circuit, I get average power, which is 1 over T, 0 to T, Vt square dt. So that is what we got before. So DC circuit, you have this power. Now I can argue, if I equate these two powers, I can find this equivalent DC source, I can generate the same amount of heat. So I can write 1 over Tr, 0 to T, Vt dt is equal Vrms squared over R. From here, I can get very important formula. Vrms is equal, squared is equal 1 over T, 0 to T, Vt squared dt. So I can write now Vrms is equal square root of 1 over T, 0 to T, Vt squared dt. So this is for the voltage. Similar way I can follow, and I can do for any other type of AC quantities like RMS current. I can define it this way. So this is how we define instantaneous RMS value for a circuit. Now, as we discussed before, like our voltages are sinusoidal or cosine nature for many of electrical circuits. So if it is cosine nature, if this time period is T and T 2 pi omega, therefore you can write this waveform in an equation like Vt is equal, if this peak value is Vm cosine omega t form. So you can think like why we select sinusoidal waveform, because a lot of circuits you have generators generate sinusoidal waveform. And the sinusoidal waveform has very less interference, no noise. So the electrical engineers prefer to work with sinusoidal waveform. They apply sinusoidal to a different circuit. And the response of a linear circuit, when you give a sinusoidal input, the response also sinusoidal. Therefore, sinusoidal circuits play an important role. So we first calculate the RMS value for sinusoidal or cosine. Cosine wave. So I can write 1 over T, 0 to T, Vt squared dt. So Vt, instantaneous value, time dependent value with time, Vm cosine omega t. Therefore, one can write Vrms is equal 1 over T, 0 to T, Vm squared cosine squared omega t dt. Now, how do you integrate this part? That's important. Now you know cosine 2a is equal to 2 times cosine squared a minus 1. Therefore, I can write cosine squared a is equal cos 2a plus 1 divided by 2. If this angle is a, 2 times that angle comes. Since my angle is here omega t, so I should get 2 times that angle. So I can write therefore VRMS is equal 1 over t 0 to t Vm squared. Now I can substitute cosine squared omega t is 1 plus cosine 2 omega t divided by 2 dt. So very important formula. So how do you simplify this further? Now I can integrate this one. Vm, because integration, summation of integration, you can integrate two functions separately, right? One by one. Vm squared over 2. When you integrate with dt, you get t. The limits are 0 to t. And other part, you get now you see this is for a whole cycle, whole period, 0 to t period. So full time period. So what does that mean? Full time period. When you integrate, you get positive area and the negative area, again positive area. The summation is negative area plus positive area is 0. So this whole term goes to 0. You can also try, because cosine omega t sine omega t, when you substitute the limit, you can also prove that it is 0, right? Because I can integrate it that this way too if I want. So I can do it like 1 over t. I can write Vm squared when I substitute this one t over 2 plus I can integrate this one cosine omega t. When I integrate, I get sine 2 omega t. Inside the function derivative is 2 omega, so this divided by 2 omega then. And my limit will be this way. I can do it that way as well. So what do I get? 1 over t Em squared t over 2. I get sine 2 omega t over 4 omega. So I know 2 pi over t is omega. So 2 omega t will be 4 pi. So this will be sine 4 pi. Sine 4 pi is 0. So this is 0 therefore. So I get Em squared over root 2 is VRMS. So this is how we prove sinusoidal waveform RMS value is peak value divided by root. So this is very important formula. So if it is a voltage waveform, as I mentioned before, you have like this, the peak value is Vm, your RMS value is somewhere here. So this divided by root. Remember, this is true only for the sinusoidal waveform. Not always it's true for other waveforms. Think you have like this type of waveform. This is also alternating waveform. It's repeating the value Vm with negative Vm. And my time period is from here to here, t. My time period is t here to here. So you can argue with the same formula, your RMS value will be square root of 1 over t, 0 to t, Vt square dt. So what is this? 1 over t, 0 to t, Vt. So for the, I can write the integration is by part. 0 to t by 2, Vt squared dt plus 1 over t, t by 2 to t, Vt squared dt. So you know t by 2 is here, t is here. Now till t by 2, my value is Vm. Therefore, I can write VRMS is equal 1 over T. Till this part, my waveform is 0 to T by 2 Vm squared dt plus 1 over T, T by 2 to T. My waveform, this part, T by 2 to T, it is negative Vm. So negative Vm squared dt. So what do I get here? 1 over T, Vm squared T by 2. And what do I get here? 1 over T, Vm squared T by 2. Right? So when I simplify this, I get Vm squared square root, which is Vm. So in this waveform, your RMS value is same as peak value. So RMS value is equal to square root peak value divided by root to get true only for the sinusoidal. Other type of waveform, you get different values. So you need to derive based on the voltage waveform nature to calculate the RMS value. So this is important, and you need to remember it in mind when you calculate the RMS value. In more general word, like when you use your ammeter, the ammeters will display RMS current, RMS voltages, and when you measure the volt socket voltage 120, that means your RMS value. So your bulbs 120 volt AC bulb, that means that voltage need to be applied across the bulb will be 120 volt. That is RMS voltage. Keep that in mind. So in the another video, we will discuss about the loads and how to select these bulbs and everything from the shop. So then we will discuss those parameters in detail. I hope this video will give you some overview about your RMS value calculation. Thank you. Bye-bye.